Today, we are diving into a huge, fundamental problem that plagues even the most advanced AI models out there. And more importantly, we're going to look at a brand new, kind of revolutionary way to solve it. We're talking about giving AI a much better memory.
So, have you ever had this happen? You're in a deep, really complex conversation with an AI. You're feeding it documents, a long chat history, and for a moment, it's absolutely brilliant. And then, poof, gone. It completely forgets what you were just talking about just minutes ago. It's a super frustrating and really common problem, even with the top-tier systems.
You know, this isn't just you imagining things. It actually has a name. It's called context rot. It's this phenomenon where an AI's performance just gets worse and worse the more information you try to cram into its memory. And I want to be clear, this isn't a problem with last year's models. We're talking about the absolute cutting-edge frontier models of today. They all suffer from this.
And this right here illustrates the problem perfectly. On the left, you've got your standard large language model. You see that line? As you feed it more and more information, its performance just takes a nosedive. It falls right off a cliff. But on the right, that's the new approach we're talking about today, the Recursive Language Model, or RLM for short. Just look at that. The performance stays strong, it stays consistent, even when the amount of input information is massive. So, what have we been doing about this until now? Well, the main truck has been summarization, or what some people call context compaction. The AI basically squishes down the older parts of the conversation to make room for new stuff. But you can probably guess the problem, right? You end up losing all the crucial details. It's like throwing away the specific steps of a recipe just so you can remember the name of the dish. It's not a great solution.
And that brings us to this new idea, the recursive solution. It's a totally different way of thinking about the problem. See, the core insight here is this. Instead of just trying to give the AI a bigger and bigger memory, what if we gave it a smarter way to use its memory?
And here is the big idea, the key insight from the paper. It says we should stop trying to stuff these gigantic prompts directly into the AI's brain. Instead, what if we treat that long prompt as an external environment? Something the AI can poke and prod and interact with using tools, almost like a programmer interacts with a database.
So how does this actually work in practice? I mean, how do you program a memory and turn a prompt into something interactive? Well, the process is actually surprisingly clever and elegant.
This diagram kind of gives you the whole picture. The AI isn't just passively reading a wall of text anymore. It's actually operating inside a programming environment. The entire long prompt is just treated as a single variable. And from there, it can write its own code to mess with that variable. And, you see on the right, it can even call up copies of itself to go work on smaller pieces of the problem.
Let's break this down into 4 simple steps, because it's actually pretty cool. First, the entire prompt gets loaded in as a variable. Let's call it context. Second, the AI itself writes code to search or slice up that context variable. Third, and this is the really wild recursive part, it calls for help. It literally spawns smaller versions of itself to go tackle subproblems. And finally, it acts like a project manager, gathering up all the answers from its little helpers and piecing them together into one final comprehensive response.
Okay, so that all sounds pretty great in theory, but does it actually work? How does it stack up in the real world? Let's take a look at the results, because this is where things get really exciting. Just look at these numbers, seriously. On a task that involved reasoning over 1,000 documents, the standard model scored 0. A big fat 0%. It was literally an impossible task for it. The RLM version, it scored over 91%. And check out the next task, a more than 1,000 times improvement. This isn't just a small bump, people. This is a total game changer.
All right, so whenever you hear about some powerful new AI technique, there's always that one question that pops into your head, right? The practical question, what's this going to cost? Is this thing going to be way too expensive to actually use?
Well, the answer is, it's a little complicated. On average, the median cost of using an RLM is actually comparable to or sometimes even cheaper than a standard model. But here's the catch. The runtime, the time it takes to get an answer, can be all over the place. And that's because the RLM isn't just spitting out text. It's actively thinking. It's debugging. It's running this whole multi-step process to actually solve the problem.
But you know what? This is where it gets really fascinating. Way beyond just having a better memory. Because the AI is sitting in this programming environment, it starts to develop its own clever strategies for how to solve problems efficiently. And these are emergent behaviors, things it was never explicitly taught how to do.
So for example, it learns to filter.
It writes code to search for specific keywords so it doesn't have to waste time reading millions of tokens of text. It learns to chunk big problems into smaller, more manageable pieces. It even learns to verify its own work, using those subcalls to double-check facts and reduce errors. And then finally, it learns to stitch all those little pieces back together into one coherent final answer. It's incredible.
And hey, this isn't just some abstract theory. This right here is actual code that was written by the LLM. You can see it. It's defining keywords, it's searching for little snippets of information, and it's processing data in batches before it puts together the final result. It's acting less like a text parrot and a lot more like a creative software engineer.
So let's zoom out for a second. What does all of this really mean for the future of AI? Because this is way more than just a small incremental improvement.
On a purely practical level, it means AIs can now handle inputs up to 2 orders of magnitude. That's 100 times larger than what their built-in context windows can handle. We are talking about processing entire code bases, massive research archives, or having conversations that last for days and days without forgetting a single thing. I love this analogy because it sums it up perfectly. It's like we've given a genius who just happens to have terrible short-term memory a perfect searchable notebook, a library card to look anything up, and the power to delegate tasks to a whole team of junior assistants. It is a massive, massive upgrading capability.
And the potential here goes even deeper. You can think of these multi-step solutions as a real form of machine reasoning. And what's really crucial is that we can collect these successful reasoning paths and use them as training data. We can actually teach future models to become even better, more efficient problem solvers from day one.
So, all of this leaves us with one final gigantic question to chew on. Once an AI can ingest, understand, and reason over not just a single document, but an entire library's worth of information, what kinds of problems could we even ask it to solve? What new scientific discoveries, what complex engineering challenges, what creative breakthroughs might suddenly become possible? That right there is the future that this technology